Whether everybody able to record this?
Yes, sir.
Okay, so I told you active class, ref dash, subclass, silk screen top. Okay, same way what we have done here, go here, add text option, active class ref dash, subclass silk screen top, click here top side, right here ref hash. Okay, this ref hash and a star will automatically change once you link your schematic symbol to this footprint symbol. This ref will become D1, D2, D3, R1, R2, R3, LD1, LD2, LD3. Guys, understood? This both ref star and hash is there. It will automatically change once you link it with the schematic symbol. Guys, clear?
Yes, sir.
Yes, sir.
Okay. So silk is over. Okay. Now we have to give some protection. Protection means our component should not touch or overlap other components. By the way, it's somewhere it is overlapping, so it should show error, right? No. So there's something called placement courtyard or placement boundary, so that we have to at least protect from that area from the other components. If it that is coming in contact, it will show the error. Okay. So Yogesh, not able to record, huh? Okay. Start recording, Yogesh. Okay. Okay. So here if you see, if we are not providing the placement boundaries or any boundaries, so if it touch and overlap, it will not show any error in our PCB. So there's something called here placement boundary. Okay, or place bound top. We're talking about its topic is placement boundary. Placement boundary. Okay, boundary means we have, suppose we have a component here and it is having two pads. Two pads here. So in your design, suppose another component is there. If it is touching or overlapping, it should show some error, no? Right? Because it can cause shortage. Okay. So suppose some component is showing, it has to maintain some gap, or it has to tell you can't touch because I am protecting with some boundary. Okay, so that is called placement boundary. Okay, in this we have to draw a protection line like this, so that it will tell you cannot come into this area. Okay, so this is called placement boundary. Okay, so this placement boundary at least 0.2 mm required from the our silk screen area. From silk screen drawing to this minimum requirement is 0.2 mm. This placement boundaries depends on the DFM or DFA. Okay, each company they are maintaining their own DFA and DFM system, so they will tell from component to component gap how much it can be, minimum gap. Okay, so that comes under DFM or DFA. So company will be having chart. Okay, so 0805 to other components, how much gap I have to maintain. Okay, BGA to how much gap I have to maintain. Throughout to this package, how much gap I have to maintain. Okay, so that chart will be available for the company, so you can use that chart. Okay, it will be available. They will definitely give you if you are drawing this, or else if you are not getting in data, so minimum maintain 0.2 mm. Minimum requirement is from the boundary from the silk screen boundary to this boundary, minimum 0.2 mm gap required. Right? Guys, is that clear? So here active class will be PAC package geometry subclass place bound top. Okay, see this how I am doing it. Go to here, edit or Z copy shape, or else in shape it is there or not. It is not there. Okay, go to here, edit and take here Z copy shape. Okay, then edit Z copy shape, go to your options, choose your active class, package geometry, subclass, place bound, top. Okay, and here you keep expand how much, 0.2 mm, and then click on the silk screen line. Now see, one boundary has came automatic. Guys, can you see this boundary? Hello.
Yes, sir. Yes.
Okay, and after clicking this, see in command console it is telling something here, one copy made with the offset of this. See here, copy is made, place bound boundary, copy is made here. Okay, how I have done, I'll tell again. Go to edit, Z copy shape, options, here package geometry, here choose place bound top, here expand means outside, contract means inside. If I take here contract, now see here what is happening. Inside one drawing is coming, right? Oops, choose here expand and click here on this line. Now see. Oh. See here. This line came. This line you can change as per your wish. Package geometry. Place bound top. Change, you can color as you want. You can make here red because this is the boundary for something. Now guys, I told you it should not cross it. See, our component will be protected from this, but this boundary has left our silk screen, right? Because to create this place bound top, to create this copy automatically from this edit and Z copy, we need a closed loop. That closed loop is this. See here, this is a closed loop and this is not a closed loop, right? So but this has to cover, so it has not covered, then you have to do some manual things. Okay, go to your shape, choose select shape, click this. If you click, it will be selected here. See, shape having on corners, and now these corners you can expand manually. Now see, I click and done. Guys, this is clear. Okay, next is place bound top done. Next we are coming here, height. 8th is mentioning height. 9th, height of the component. Height. As I told you earlier, we need to understand the component height after soldering on the PCB. Here 2.1, and also we have mentioned here height 6th number component height. Okay, height is how much? 2.1 mm, right? So now how to mention the height? You see here, go to again edit, go to here properties, and then come here, click on the placement boundary. Why you are maintaining height? To show the maximum height, how much it can cover. So go to your edit, properties, come to this, click on the our placement boundary. It will show here no property as of now, right? is showing here no height as of now, right? So in this scroll bar, just scroll and found here package max height. See here, package max height. It will come here. Again, you will be confused. See here, edit properties. Click on here. So this will come. This window will come once you have arranged. Now in this, you find here package height max. Package height max. Here you write what is there, 2.1 mm. Click here, apply. Now see. If you see here, see what is saying here. Component height we have maintained how much? 2.1 mm. Correct now? So what we'll do, I will reset this. I'll delete this and see. If you see here, now that height I have deleted. Suppose reset. Oh, once assigned means assigned. So we can't do. Now see, this is earlier without height. See here, no height. So I'll show you the 3D something like. Click on 3D here to know the height profile of this. Click here, okay. This is before assigning. See here. This height you see, guys. This height you see. Correct? No, this is we have not yet assigned. We have deleted the height, what we have given. Guys, you see this height. Okay. Now we will assign the height. File, sorry, edit, properties. Here, package max height. I am assigning here 2.1 mm. Apply. Okay. Now see the 3D body. Guys, is it the same height what earlier was there? Hello?
No, sir, no.
So earlier it has taken random height. Okay. But once we have mentioned, so it has taken our given height. Okay. Clear this point? Now, something like we have a one more term, manufacturing no probe top, but you don't understand right now. I'll teach you later that no probe top. Just we are going for the next 3D assignment. Before that, we have to do one more thing. Here, first we will assign the 3D file assignment. 3D, how to assign the 3D. Next is 9th, 10th is 3D assignment. Okay. So 3D assignment, how to assign the 3 parts over here. Just go to here, setup. And if you see here, a step package mapping is there, right? I hope everybody download their step files. Okay. So setup step package mapping. Click here, okay. So this step package will come. This window will come. Okay. In this, just click on here overlay and hide the board. Both you keep on. Okay. Now this list will show you all the downloaded your 3D parts. If you have linked your 3D folder in the user profiles, so it will show here all the available 3D parts in your that particular folder, right? So here what we need LED. See LED, correct? No, if you click here LED, it will come here, right? And this LED will be something like that. Okay, you see here it is not properly assigned. Okay, our component is like this. Suppose you take here front component is like this, and our LED part is like this. Correct? If you see here, left, back. If you see here, top. Okay, so component is something like this. So better you keep always here front, left, and then see component is like this, right? So just here something here given. See rotations, X rotation, Y rotations, and Z rotations. This you have to play. You have to play and make like this. How this orientation is X, Y, Z. Same like you have make like this by changing this. You make here X 90 and see what is happening. 90. Click on next block. Now see. Correct? Now this you take. Go to here again. Front. Keep here. Bring down. Now go to here top. Top. So top, just click here and bring at the center. Guys, clear? Now click here bottom. See bottom. Now click here front. Front. Okay. Then click here back. Okay. Check by I'm checking here. I have already here fixed it, but checking from back side, from top side, front right. Okay, just check everything is proper. So now click here shape and close. Now we have done that. Whether it is correct or not, how to verify? So verify will be like this. Take here 3D button, click here OK. Now see this. Guys, one setting you have to do in your 3D. Go to your setup, preferences, and color themes. You choose your dark green. For everybody, these settings you have to do at the first time, dark green, and apply and OK. Okay, now, guys, here two parts are there. This is called rotation. See, this is called rotations. Okay, and this is called movement, moving. Okay, so for rotation of 3D part, for rotation of 3D part, how to rotate? We have a command. Command is for rotation. I'm telling you guys. Okay, long press shift key plus long press mouse wheel. Both you have to long press and move mouse. Okay, your component will be started rotating. Okay, this for rotation of the 3D part. Now move. Move means for moving. For move. Long press click and long press of mouse wheel. Okay, and move your mouse, your component will be moved. Guys, if you see here in 3D part, just go here, 3D button will come, click here, it will show the 3D. Okay, now see my mouse pointer is arrow type. Okay, I have long press my mouse wheel. Now see the mouse pointer will become like a hand signal. See here. Now I am moving. This is called moving. Okay. Now I am long pressing the shift key and long press the my mouse wheel, and now I am rotating, moving my mouse. See here. This is called rotation. Okay. Guys, that clear?
Yes, sir.
So close this. Next is dimensioning. Last topic is dimensioning. 10th, what topic it is? This is the last topic of the footprint. 10th, 11th. Dimensioning. Guys, what dimensions means? What they have given here, this dimension, what you have taken here, this will be justified there, whether we have done correct or not. Right? So how like they have given here dimensions, same dimensions we have to give in our footprint. Okay. So for that, active class will be package geometry subclass equals to what? Dimension. Okay. Guys, don't by mistake also you should not select here board geometry by mistake also, because board geometry is PCB. We are doing it for footprint, for package symbol, for land pattern. So always our active class will be package geometry. Only at reference design time the active class will change to the ref des. Rest all the times it will be always package geometry. Keep in mind, always keep in mind is where for the active class and subclass. Otherwise, it will be a problem for you. Okay. So next, go to your dimension drafting and check here. Click on dimension environment. Okay. So dimension drafting, dimension environment. Go to options. You see here. Here package geometry is not available, right? Guys, can you see here? In this active class, package geometry is not available, right? Everybody?
Yes, sir.
Tell me, guys, everybody, is the package geometry available? No, right? Hello? Guys, everybody slept off. Bhagya? Hello? Girish, are you there?
Yes, sir.
Yes, sir.
Available, sir.
Subbu, Yogesh. Guys, always be energetic. Even I am also working. Okay. I had one class, again came back to this class. Okay. So try to be energetic. Okay. This is the last topic we're discussing. Okay. So guys, for dimensioning, we need package geometry. So here go dimension drafting. Select here dimensions environment. And if you see here in the active class, the package geometry is not available, right? Is it available package geometry here?
No.
No, sir, no.
So we have to make our own class. Okay. So how to make own class? Go to your setup and here subclass. Okay. In subclass, you click on package geometry here double dot and write a dimension. DIMENSION dimension and enter. Click here OK. Okay. Now see dimension drafting, dimension environment. If I go here, package geometry is available, right? Earlier this was there, it was not there. Now I made a subclass. So how I made? I have gone in setup, then here subclass, I selected here package geometry, I done here dimension and entered, click here, okay. Now it is coming. So go here dimension drafting, go to here package geometry, here dimension, change the color as we want, any color you want. Just right click in blank space area, go to parameters, come here, choose here unit in millimeter, go to your text, choose your text block 1, go to your lines, and here you give 0.5 mm you give, 0.5 mm you give, here also 0.5, here also 0.5. Distance from the element you give here 0, here you give 0.5. Okay, click here apply and okay. Again come back here, right click and linear dimension. Linear means then you can check here, you first come to the pin, right click, a snap pick to pin. Now see one point coming on the pin, second pin, right click, a snap pick to pin. Now showing here 3 mm pitch. Next, if you bring your mouse over the here on this line, it will show the line. Just click and see here. Clear? Now for assembly also 2.8, now this one we have to do assembly we have to do your lines. Okay, now come to the line. Now this is our what? Now here. Okay, next is this is called linear dimension, only length and width. Now to know this, we need to go here for the leader, no, diametral. Okay, diametral. Then click here. Okay, next this one. Next, see here. Guys, is that clear? Guys, okay?
Yes, sir.
Now, next is final is saving. Okay, saving means file and save, or here save, or press Ctrl S. So save here. So now saving. After saving, you should check here your this command console, this component name .dra. Guys, see these two lines. Component name .dra saved to disk, symbol led means component name again .psm created. So after saving, these two .dra and .psm, this both should create. Okay, if only one is missing, so means that is not done correctly. That means you have not done correctly. At the end of your design, your component name .psm and .dra, both should create. If one is missing, so there's something is problem in there. Guys, clear? We have saved it. Now if you want to see the 3D, you can see, press here 3 and see here. See here. Looking good, no?
Yes, sir.
Yes. So for the first time, it may take for you for 1 hour to create with full process the footprints. Okay. But once you get in the practice, it will become 10 to 5 minutes. Okay. This involves after full practice, it should not take more than 2 to 3 minutes. Okay. Once your speed comes 3 to 5 minutes for this kind of symbols, so you think I am at the coming in the average, but this should not take more than 2 to 3 minutes. Okay, guys, is that clear?
Yes,
Yes, sir.
Okay, so these symbols, so once this speed comes under 5 minutes, so you think I am okay for the footprints. Footprints is basically backbone of the PCBs. Once you done some footprints with good speed, that means you are getting some confidence for the design. Okay, that's why it's called backbone of the PCB. Okay, try to create the max to max footprints, speed up your this one, what your speed. Okay, and start creation. So this is done. Same way you have to create footprints for the SMD packages, footprints for the other packages, means other components. What is the easy you can feel, you can create. At least 2 pedestacks are there in that components, that at least you can create capacitor, resistors. Okay,
yes,
guys, clear?
yes,
So start creating. See the videos. First of all, see video at one time. Write each and every points what it is required here, how sequence wise and plan wise I have explained. Okay, if you write at one time and then you follow by your own, it will be better and you will get some speed. Okay, guys, clear?
yes, sir.
Okay, fine. Bye. Good night. Take care, everybody.
Bye, sir. Good night.
Yes, sir. Bye.
Thank you, sir.
Thank you, madam.